Welcome to The Explainer. So, for the longest time, the story of artificial intelligence was literally just about brute force, right? Bigger data centers, crazy high parameter counts, and this, frankly, unsustainable power consumption. But if we look at the industry reports from the first half of 2026, the narrative completely flipped. Today, we're diving into a massive technological pivot. We're going to look at how the AI industry engineered its way out of a huge computational bottleneck. And spoiler alert, it has everything to do with incredible breakthroughs like the Kimi-Linear attention architecture, the explosion of multi-agent swarms, and some serious money pouring into quantum computing. Let's get into it. Okay, to really grasp this shift, we first have to talk about what happens when traditional AI models get a little too big for their own good. It's all about quadratic scaling limits. Think of it like this. In a standard multi-head attention model, every single word or token has to constantly look back at every other word that came before it just to understand the context. So if you double the size of the document you're feeding it, the computing power required doesn't just double, it literally quadruples. When companies tried pushing context windows into the millions of tokens to analyze massive code bases or years of financial data, the math just completely broke down. The models became way too slow, way too expensive, and way too power-hungry to be sustainable. So, how did the industry fix this? Well, here's our roadmap to figure that out. First, we'll unpack the AI architecture evolution. Then, we'll dive into the rise of agentic swarms. Third, we'll explore local and private AI. And finally, we'll look ahead at the quantum hardware horizon. All right, kicking things off with Section 1, the AI architecture evolution, or basically how developers learned to do a lot more with a lot less. If you really want to understand the massive leap that happened in 2026, you absolutely have to look under the hood. Standard models were basically choking on their own memory requirements. But then, researchers dropped new architectures like Kimi-Linear. And man, it was a total game changer. Kimi-Linear is this brilliant hybrid design. It uses linear recurrence, which basically means it processes information in a super efficient straight line without having to look back constantly. But it blends that with selective full attention, which it only fires up when it desperately needs deep context. This completely shattered those old quadratic limits. It enabled a massive 1 million token context window while keeping compute costs totally flat. And at the same time, you had models like DeepSeek v3.2 taking a totally different path, using sparse attention, where the model only focuses on the tiniest fraction of relevant data at any given millisecond. Because of these breakthroughs, open-weight developers were suddenly iterating at absolute breakneck speed. Just look at how fast this moved. DeepSeek drops sparse attention in December of 2025. Barely a month later, Moonshot AI launches Kimi-Key 2.5, heavily utilizing these new efficient architectures to directly challenge closed models in coding. Then by February, Inception throws a total curveball with Mercury 2, which was an LLM built on a diffusion architecture that could generate over 1,000 tokens per second. And by June, Minimax drops M3, natively combining all these agentic capabilities together. By making it radically cheaper to train and run these models, the core AI engine essentially became a standardized, super fast-evolving commodity. Which brings us right to Section 2, the rise of agentic swarms, moving AI from just assisting us to actually executing complex tasks. This newfound efficiency totally flipped the script on software engineering. Enter vibe coding. Yeah, that's really what they call it. Instead of a human acting as a typist, writing line after line of code, the human becomes a director. Or honestly, more like an ant farmer. You point, you highlight, you just speak your high-level intent out loud, and a swarm of specialized, highly efficient AI agents operating in parallel goes off to fetch the necessary files, read the documentation, and write the actual code for you. It's an entirely intent-driven workflow. And industry leaders quickly realized this was going to fundamentally destroy the old way we write software. At the NYC AI Engineering Code Summit, the consensus was incredibly clear. The era of the giant AI assistant just sitting passively in a traditional code editor was over. Traditional IDEs were becoming a relic of the past, entirely replaced by these multi-agent swarms in dynamic AI-first workspaces that care way more about context engineering than syntax highlighting. To put a real number on just how valuable this shift is, try $60 billion. That was the massive valuation SpaceX placed on the coding startup Cursor. And interestingly, Cursor built its success heavily upon the hyper-efficient Kimi-Key 2.5 architecture we talked about earlier, utilizing it for their Composer 2.5 feature. Seeing an acquisition offer of $60 billion for a coding startup really tells you exactly how much financial value the market places on truly automating software engineering. But hey, it wasn't all sunshine and flawless code. These swarms definitely aren't perfect yet. While vibe coding is incredible for short bursts of work, look what happens on the SWE marathon benchmark, which strings together 20 multi-hour engineering tasks. Over those long, grueling hours, even the absolute best frontier models fail 81% of the time. They enter what developers actually call the dumb zone, getting completely overwhelmed by context pollution. And, this is exactly why researchers fought so hard for architectures like Kimi-Linear in the first place, to maintain strict focus over massive context windows without just completely degrading. Okay, moving on to Section 3, Local and Private AI, where security finally meets efficiency. Running all those massive agent swarms in the cloud created a glaring problem. Enterprise IT security teams were straight up blocking AI tools because they were terrified of data leakage. I mean, think about it. A lawyer absolutely cannot have an AI browsing highly confidential case files on a public server. A financial analyst can't have proprietary data getting mixed up in some cloud provider's training run. The industry desperately needed a way to keep data local and secure without sacrificing the sheer intelligence of the big frontier models. So Google's private AI compute solved this puzzle using hybrid agentic inference. Imagine that private equity analyst working with highly sensitive Excel files. Step 1, a fast, super efficient local AI model wakes up directly on their laptop and reads the files. Step 2, it automatically flags and redacts names, emails, and financial markers. Step 3, only that sanitized, completely clean data is sent up to the cloud for the heavy-duty reasoning. It is literally the perfect marriage of local security and massive cloud intelligence. And because of the extreme efficiency we talked about back in Section 1, your everyday smartphone can now serve as a private, offline AI powerhouse. Thanks to quantization-aware training, developers literally shrank models like Gemma 4 down to under 1 gigabyte. You don't even need an internet connection anymore. This means your device can process multimodal inputs, like analyzing a video or listening to an audio recording, with zero latency and absolute ironclad privacy. Finally, let's wrap things up with Section 4, the quantum hardware horizon. Even with all this amazing software efficiency, classical silicon is just hitting its physical limits. The power grids are simply maxed out. In Europe, operators are having to invent entirely new grid-enhancing technologies just to keep standard AI data centers running. That is exactly why the US government made a massive $2.01 billion CHIPS Act investment in May 2026. They stopped treating quantum computing like a lab experiment and started treating it as critical infrastructure. They awarded IBM $1 billion alone just to build a domestic quantum wafer manufacturing foundry. And IBM is leaning in hard, committing $10 billion to move quantum out of the lab and into commercial reality within 3 years. They're targeting a machine called Quantum Starling. They're promising a system that can execute up to 100 million quantum operations using 200 logical qubits. Now, logical is the key word there. It means these qubits are error-corrected and stable, so they can do vastly more computational heavy lifting with way less overhead. They are firmly betting that by 2029, these machines will unlock problems that classical computers simply cannot solve. And you guys, this isn't science fiction anymore. Companies like Quantinuum are already mapping these logical qubits to massive real-world problems. They're using hybrid quantum classical workflows to map out protein binding energies, to speed up early-stage drug discovery. They're utilizing quantum machine learning to spot high-dimensional transactional fraud in global finance. They are bringing a level of computational power to the table that is eventually going to make today's cutting-edge AI models look like pocket calculators. So to wrap up this explainer, I really want to leave you with a provocative thought about our place in this radically automated future. We started with architectures like Kimi-Linear, making AI incredibly fast and efficient. That efficiency birthed swarms that can literally write their own code, and powerful models running totally privately on our phones. Now, with quantum computing poised to shatter our hardware limits entirely, the technical barrier between having a great idea and actually executing it is just vanishing. If the machine handles the coding, the data privacy, and the sheer computational heavy lifting, your only real job left is the vision. So the question is, are you ready to direct a swarm? Thank you so much for joining me for this explainer, and I'll catch you in the next one.